and welcome to this physics tutorial. Okay, now here is a question on velocity and acceleration. Now let's read the question together. A car comes to a stop from a speed of 30 meters per second in a distance of 840 meters. So which means the total distance in this case has to be 840 meters because it is given that the driver brakes so as to produce a deceleration of 1/2 meters per second square to begin with, and then brakes harder to produce a deceleration of 3/2 meters per second square. Okay, so which means now what we are given here is that the car comes to rest, okay? It comes to a stop, okay, when the distance is 840 meters. Now, but first, the driver brakes so as to produce a deceleration of 1/2 meters per second square to begin with, and then brakes harder to produce another deceleration, which is 3/2 meters per second square. So we're asked to find the speed of the car at the instant when the deceleration is increased. Now, deceleration increase in this case, that is, we're asked to find the speed when the deceleration changes, okay, and the total time the car takes to stop. So which means now there are two phases in this case. Now the first phase we have a distance. Okay, let me analyze the problem. Okay, so we are given that a car comes to a stop from a speed of 30 meters per second. So we can say initial speed initial speed of car which is u, is equals to 30 meters per second in a distance of 840 meters. So which means the total distance traveled, or the total distance covered, the total distance traveled is 840 meters. So now, like I said, there are two phases involved. Now, during the first phase, okay, we have that the driver brakes so as to produce a deceleration of 1/2 meters per second square to begin with. So which means the first deceleration is what we have as negative 0.5 meters per second square. Okay, this is the first deceleration. Okay, and then brakes harder to produce another deceleration of 3/2 meters per second square. So in this case, we have second deceleration. Second deceleration is given to be 3/2, and that to be 1.5, negative 1.5 meters per second square. So now the question is for us to calculate the final speed. So for the decelerations, in this case, we have that during the first phase, okay, we need to calculate the distance, okay, the distance covered during the first phase, and then the time. We also need to calculate the time because the second question here reads, and the total time the car takes to stop. So which means for the car, okay, to come to a stop from a speed, this is the initial speed of 30 meters per second, okay, to a distance of 840 meters, which is the total distance. So first thing first, now what we need to understand as far as the question is concerned is that now the car, comes to a stop from an initial speed of 30 meters per second. So we need to what? We need to calculate the speed, okay? That is the speed during the first deceleration. That is the final speed. Now the final speed during the second phase will be 0 because that is when we have that that is when we have that the deceleration changes. So as the deceleration changes, then it means that the speed, okay, during the second phase, okay, which now the final speed during the second phase has to be equals to 0. So now we're going to employ one of the equations of kinematics in this case, and that is the equation. Okay, before I introduce the equation, so like I said, so we can then say x1 represents distance travel, distance traveled during the first phase, while x2 represents distance traveled. Like I said, there are two phases. These two phases are involved during the second phase. So we also need to calculate T1 and T2, which represent the corresponding time, the corresponding times, the corresponding times during first and second, during first and second phase. Okay, so now let me now introduce the equation. Okay, now applying the equation of kinematics, that is the v squared equals to u squared, okay, u squared plus 2as. Okay, so for the first phase, okay, during the first phase, let's calculate that of the first phase. Okay, now remember, we're also going to have v, that is for first phase, speed during first phase. Then v2, that will be the speed, during second phase. Okay, so that is also important. So now, so during the first phase, we have that v squared will be equals to u squared plus 2a1 then x1. So which means in this case, s equals to x1. Okay, a equals to, that is the a equals to negative. Okay, that's a is negative. Okay, a is negative. All right, so now we have here that the initial speed is 30. So this is going to be v1 squared equals to 30 squared plus 2 multiplied by, this will be minus 0.5, then multiplied by x1, So in this case, we're going to have this to be, so this will be equals to 900 minus x1 equals to v1 squared. So now let's note this. Remember I said v1 represents the velocity during the first phase, but the velocity during the second phase, which is the velocity or the speed rather, the speed as the deceleration changes or increased, okay, that will be equals to 0. So we then again write second phase, for the second phase, because the direction of motion in this case is taken to be positive. So for the second phase, we again write s equals to x2, then a is negative. Okay, a2 is negative. All right, so we then what? Use the formula v2 squared. Okay, v2 squared equals to that will be u squared, that is v1 squared. Yes, it will be v1 squared. Okay, then plus 2 multiplied by, so we are using 2a2 times x2, so that v2 squared will be equals to, now we have v1 squared, okay, minus 2 multiplied by, so the second deceleration is minus 1.5. Okay, so this is minus 1.5 meters per second. So for this one, okay, we have this to be negative 0.5 meters per second square. So this is minus 1.5, okay, 1.5 meters per second, then multiply by x2, Then again, we know that the velocity during the second phase must be equals to 0. So when this is equals to 0, so what we have here is v1 squared minus, this is 3x2. So that 3x2 will be equals to v1 squared. Then I can write here that x2 equals to v1 squared, v1 squared divided by 3. That's x2. That's x2. So now this is our equation 1, okay, and this is our equation 2. Okay, that's our equation 2. Now let's go back to what we are given as the total distance. The total distance traveled is 840 meters. So we know that total distance equals 840 meters, and that will be x1 plus x2 equals to 840. Okay, so now we know that x1, if I make x1 the subject of the formula, x1 from here, x1 will be equals to v1 squared minus 900. Is that it? No, it will be 900 minus v1 squared. That will be x1. All right, so x1 will be 900 minus v1 squared, while x2 is v1 squared over 3 equals to 840. Equals to 840. All right, so let's not forget that we want to calculate v1, because I said during the second phase the velocity will be equals to 0, and that's exactly what we have here. So from here, okay, so let me write it here. So we have from here, this is going to be v1 squared over 30 over 3 minus v1 squared equals to, I'm going to move this to the left hand side, that will be 840 minus 900. Okay, so this will be negative 60. Okay, so if I now simplifying this will be v1 squared minus 3v1 squared divided by 3. So this will be minus 2v1 squared equals to minus 60 times 3. So that minus 2v1 squared equals to, this is going to be 100 and minus 180. Okay, that is after I move 900 to the right hand side, I got from 840 minus 900, that will be minus 60. Okay, then we have v1 squared over 3 minus v1 squared. That will be minus 2v1 squared. Okay, so in this case, if I divide both sides by minus 2, okay, v1 is going to be equals to v1 squared will be equals to, so dividing both sides by minus 2, I'm going to get, we're going to have positive 90. Okay, that is 90, because 2 times 90 is what? 180. So that v1 will be equals to square root of 90 in meters per second. So that v1 will be equals to, that will be 3 root 10. Yes, this is 3 root 10 meters per second. So this is the velocity during the first phase. Let's not forget that the velocity during the second phase is 0 meters per second. It is equals to 0. Okay, is equals to 0. All right, so now we can now calculate the value of x1 and x2. Okay, now that we know the value of v1, so x1, now we also know from here that x2 is what? v1 squared divided by what? 3. So let's calculate x1 plus x2, which is equals to 840. Now x1 is 900 minus v1, this is it here, minus v1 squared, then plus x2. x2 is, we have v1 squared divided by 3. Okay, v1 squared divided by 3 equals to 840. Equals to 840. So now we know that this will be 900 minus, so we have 3 root 10 raised to the power of 2. Then this also will be 3 root 10 raised to the power of 2. Okay, 3 root 10 raised to the power of 2. Oh, I beg your pardon, sorry. I need to calculate x1 and x2. So the value of x1 will be 900 minus 3 root 10 raised to the power of 2. So that this will be x1 equals to 900 minus, this is 9 times 10. Okay, because 3 squared is 9. Then multiply by root 10 squared is what? 10. So that will be 90. So which means the first distance traveled, that's during the first phase, that will be 810, 810 meters. Now the second distance, because we need to be sure if the distance, we need to verify rather, if our distance will be equals to 840. So for the second distance, which is, we have that to be v1 squared divided by 3. This will be x2. X2 will be equals to 3 root 10 raised to the power of 2 divided by 3. So that x2 will be equals to, this is 90. 90 divided by 3. Okay, because again, 3 squared, that's 9. Then root 10 squared, that will be 10. 10 times 9, that's 90. So this will be 30. That's 30. So which means x2 equals to 30 meters. So we can see that x1 and x2. Okay, so if we have, therefore, x1 equals to 810, while x2 equals to 30 meters. So that is the distances x1 and x2. Now let's calculate the total time. I mean the speed. We want to calculate because it said find the speed of the car at the instant. Okay, at the instant. Okay, we just calculated the speed. We calculated the speed of the car at the instant when the deceleration is increased. Because at the instant when the deceleration is increased, the speed is what? The velocity change as the display, as the deceleration also what changes, and that's equals to 0. All right, so I only calculated the value of x1 and x2 for us to be sure that the total distance is 840. Okay, now, so the next thing to do is let's calculate the total time. So we also have to calculate the total time the car takes to stop. Now, for total time is when we have t1 plus t2. So t1 is the time during the first phase. So let's use the formula, v1 equals to u naught plus a1 times t1. Okay, that's for this. So we can say that v1 is 3 root 10. v1 is 3 root 10, and we have the initial velocity to be 30. Initial velocity is 30, then minus the first deceleration, which is 0.5 multiplied by t1. So that t1 will be equals to, so I'm going to bring this to be 3 root 10 minus 30 divided by minus 0.5. Minus 0.5. Okay, let's get the value of 3 root 10. Okay, 3 root 10. So the value of 3 root 10 is, the value of 3 root 10 is 9.486, 487. 9.487, then minus 30 divided by 0.5. So that will be minus 30. Okay, we have 9.487 minus 30, which is negative 20.513 divided by 0.5. divided by 0.5. So the answer will be for T1, that will be 41.026 seconds. Okay, let's note this also. Remember, I want to calculate the total time. So during the second phase, the time, that's T2, which is time during the second phase. During the second phase. So we then use the same formula. We use V2 equals to V1, okay, plus A2 multiplied by T2. So we know that A2 is minus 1.5 meters per second square. Okay, then we know that V1 is 3 root 10 is 3 root 10 is 3 root 10. So we have A2 to be minus 1.5 meters per second squared. Then V1 is 3 root 10 meters per second. While V2 is equals to 0. So we have 0 equals to V1, which is 3 root 10. Okay, then minus 1.5 multiplied by T2. So this would be 1.5 T2 equals to 3 root 10. If we divide both sides by 1.5, okay, so this would be 2, okay, that will be 2 root 10. This is 2 root 10. That will be 2 root 10 seconds. I'll get the values later. Okay, so now, so the total time, which is T, that will be T equals to T1 plus T2. So the total time will be the first time we calculated, which is 41.026. Then add it to 2 root 10. What is 2 root 10? Now 2 root 10, that will be 6.325. 6.325. So when added together, this will be 1, then this is 5, this is 3, and then this will be 47. So the total time will be 47.4 seconds. Let's approximate it to the nearest tenth. And we've come to the end of this tutorial. It's no less pleasure. It's the joy of understanding.